So this video is going to focus in on monomials, but it's the idea of building up to this adding and subtracting of polynomials. So what is a monomial? Well, first, it could be just a number, it could be a variable, or even a product of a number and variable, or variables. It could have more than one variable. Product mean multiplication. But the idea is it also needs to have whole exponents. Okay, it can't be fractional exponents, it can't be negative exponents, it has to be whole number exponents. So the first thing to really talk about with monomials is the degree. And you might think of this as the accumulation or the total or the sum of the powers. And that's kind of what it says here. It says the degree of a monomial is the sum of the exponents of the variables in the monomial. So you're talking about what are the powers or what are the exponents of all of your variables, and you would add them together, you would sum them up, and that would be the overall degree of a monomial. The degree of a non-zero constant term, though, is 0. For example, let's say I have just the number 5. Because it doesn't have any variables with it, it is a monomial, because a monomial can be a single term, but it doesn't have a degree because it doesn't have any variables. And then last but not least, the constant 0 does not have a degree. So if the constant, the 0, it wouldn't have a degree. Also because it doesn't have any variables with it. All right, so what are some of the examples that we're talking about? Well, here are some examples of monomials. The number 10 is a monomial. It's a single term. Of course, its degree would be 0, as we just discussed, because it doesn't have any variables. But if we got to this 3x, it is also a monomial because it's one single term. There's no plus or minus sign between the 3 and the x. In fact, they are a product. They are multiplied together. But it does have a degree, and the degree is 1. And the reason the degree is 1 is because, well, the power that is attached, the exponent that is attached to the x is a 1. Now, we don't typically write the 1, but it is there, so technically I could add it. So its power or its degree is a 1. What about the one below it? Well, here's a good example of a product where there's 3 terms. There's a number, a constant part, and then 2 separate variables. Well, as was just discussed above here, the a, what is its power? Well, notice it does not have a number, so it's an automatic 1, which is why they said the degree, the total degree is the 1 plus the 2, because the a has a 1 and the b has a 2, so the total degree is a 3. Last but not least, we have another constant. We do have a variable, so that means we will get a degree other than 0. And in this case, the exponent is a 5, so the degree is 5. It also points out a couple of ideas, what is not and what is a monomial, or rather why it's not a monomial. Notice the first one. It says the column is not. 5 plus x is not a monomial. What's the reason? Well, a sum is not a monomial. I have an addition sign happening. So a sum, the addition of 2 different things, of 2 different terms, is not a monomial. Mono meaning 1. This has 2. Next, it's 2 divided by n. Now notice the detail as to why this is not a monomial. Because a monomial cannot have a variable in the denominator. So in this case, there is a variable in the denominator. It does not make it a monomial. Next one, 4 to the power of a. Here's another thing that is not a monomial because, well, a monomial cannot have a variable exponent. So that is your exponent cannot be a variable. And last but not least, we have a variable raised to a negative power, in this case, a variable raised to the -1. And in previous lessons, we knew that this means 1 over x to the first power. That negative, the negative in the exponent means it goes to the denominator, which actually breaks the above rule here. You cannot have a variable in the denominator. But it words it this way because it's a negative. It did not rewrite itself like we showed it, but it says the variable must have a whole number exponent. Whole numbers. Now, what are whole numbers again? Well, there are counting numbers. 1, 2, 3, 4, 5, whole numbers. It's not allowing us to have a negative, not allowing us to have integers. So let's do a couple of examples. Let's find the degree of a couple of problems. Example 1, 5x squared. 5x squared. Well, what is the degree of this? Well, recall that a constant, we don't count its exponent. So the only variable that we have is an x, and its exponent is a 2, so that means, well, the total degree is 2. Example 2. I again have a constant, -1/2. I have an x. What is its exponent? Well, it's not written, so we know that it is a 1. And then I have a y that is raised to the third power. So what's our degree? Well, it will be a combination or the sum of those two. Recall that that's what we said up here. The degree of a monomial is the sum of the exponents of the variables in the monomial. So 1 plus 3, that makes the degree a 4. Example 3, -3, what's the degree? Well, it does not have any x variables. And we said above that the degree of a non-zero constant, so that is just a number, is 0. So the degree here, there's no variables, so the degree is 0. Last but not least, what about here? Well, again, the constant, we don't count its power for part of the degree, but we have an x to the 6th and a y to the 2nd. If we want the total degree, we will add the powers to get just the degree, just the measure of the strength of the problem. So in this case, 6 plus 2 is 8. All right, this is your lesson, real short, on monomials. What is it? It can be a number, a variable, or a product of a number and variable together. But they have to have whole number exponents. And if you want to know the degree, which is different than asking what is the exponent, the degree is the total of all of the exponents. You simply add them based on however many variables you have. Next time, we will talk about polynomials.